Hi there. In our last section, you learned what a composite function is and how to find the differentiation of a composite function. In this section, you are going to learn what an implicit function is and how to differentiate the implicit function. So, let's begin. Implicit functions. A mathematical function which is not defined explicitly but is defined in terms of an algebraic relationship is called implicit function. It cannot be solved for independent variables. In other words, we can say that a function which cannot be separated from its independent and dependent variables is called an implicit function. Let's consider an example of an implicit function. So, look at the example x squared plus 2xy plus y squared is equal to 0. If you look at this example closely, you will see there is no way we can separate x and y, because even if we take x on this side, I still have 1x with y, or if I take y on the other side, I will still leave 1y on this side. So technically, it's impossible to separate x and y. Let's consider an example of an implicit function. Check whether the function is implicit or not. Xy is equal to cosine of x plus y. It is given that xy is equal to cosine of xy. So what I'm going to do, I'm going to separate x and y this time. So I wanted to consider the function in terms of x. So what I did, I divided this function on both sides with x. If I do that, I will get y is equal to cosine of xy over x. If you look closely, I still have a x and y together. So in this expression, I could not separate x and y. So let's try another approach. So if I take this cosine to the other side, I will convert this cosine into cosine inverse. So this is my cosine inverse x comma y, and I will leave x plus y on the other side. If you look closely, on the right side, I have x and y together, and on left side, I have x plus y. So technically, no matter what I do, I cannot separate this x and y. So I can definitely say that this function xy is equal to cosine of x plus y is an implicit function.